Hello students, in the last class we were discussing about the group 17th elements, which are also known as halogens, and we have seen some of the important physical properties as well as chemical reactions, that is chemical properties of group 17th or halogen atoms. Along with that we have seen one of the important preparation, that is preparation of chlorine, right? So with the help of Decon process also, with help of electrolytic process also, and other two simple processes by using the hydrochloric acid on potassium permanganate, right? So we have seen some of the important reaction for the preparation of chlorine also, that might be asked for 2 marks as I have already explained. And we have also learned some of the important uses of chlorine, right? So that also we have completed. And in today's class we will go through the extended part of 17 group elements or halogen atoms. So in that we'll see one or two more preparations like hydrogen chloride preparation also, and along with that the oxo acids of halogen. We'll see some of the oxo acids and their structures also we'll see, right? So we'll continue here with the hydrogen chloride, right? So in case of hydrogen chloride, the hydrogen chloride is a prepared very simple process, right? So it is prepared by heating sodium chloride with concentrated sulfuric acid, right? So whenever sodium chloride react with concentrated sulfuric acid, that is NaCl is a sodium chloride, when it reacts with concentrated H2SO4 at 470 Kelvin, at the temperature of 470 Kelvin, so it will convert into NaHSO4 along with the preparation or liberation of HCl molecule, right? So in this way we can prepare the hydrochloric acid. Generally we will call it as hydrogen chloride. So hydrogen chloride is prepared by heating sodium chloride, that is a salt, sodium chloride, with a concentrated sulfuric acid, that is H2SO4, in presence of strong acid, that is H2SO4, at the temperature range of 420 Kelvin. So it can convert into NaHSO4 along with the preparation of the desired compound, that is hydrochloric acid, or you can call it as hydrogen chloride. And if you see some of the important properties of hydrochloric acid, so it is colorless and pungent smelling gas. So generally it is colorless and it is pungent smelling gas, and it is easily liquefied to colorless liquid, right? So generally it is in the form of gas, but in the laboratory we will use it as a dilute HCl, concentrated HCl, which is in the liquid form, which means the gas can be easily liquefied to colorless liquid, right? So the hydrochloric gas is generally it is colorless. We can convert with a pressure, we can convert that into a liquid molecule, or it can be liquefied to colorless liquid, right? To colorless liquid. And the boiling point of HCl is 189 Kelvin, and the freezing point is 159 Kelvin, right? So the boiling point of HCl is 189 Kelvin and freezing point is 159 Kelvin, right? So there is a constant value, and it is extremely soluble in water, right? So hydrochloric acid can dissolve in water, it can mix with water, so therefore we generally call it as it is extremely, which means very easily, or at a very greater extent it is soluble in case of water molecule. And it is aqueous solution is generally called as hydrochloric acid, right? So whenever we mix that with water molecule, or whenever it is dissolved in water molecule, we will call it as hydrochloric acid. Otherwise it is generally called as hydrogen chloride, because it is mixing of hydrogen and chlorine gases. Whenever you mix hydrogen and chlorine gas, we can convert that into HCl, that is generally called as hydrogen chloride. But whenever this hydrogen chloride is dissolved in water, that is generally called as aqueous solution. Aqueous solution means which is in the form of water, or which is completely mixed or miscible with water. So in that condition, generally it is called as hydrochloric acid. Both are same. Hydrogen chloride is also same, and hydrochloric acid is also same thing, right? And is generally called as hydrochloric acid in presence of aqueous solution. Whenever it is dissolved in water, as I said, it will convert into hydrochloric, which is generally called as hydrochloric acid. And if you go for some of the uses of HCl or hydrochloric acid, generally in the manufacture of chlorine, we have seen already in the preparation of chlorine. So we have used along with potassium permanganate, we have used HCl, that is concentrated hydrochloric acid. Therefore in the manufacture or in the preparation of chlorine, we must use HCl also. And in the extraction of glue from bones, right? So generally in case of the fat content which is present in that right, so the body of certain animals, the glue, there is gum, right? So the gum which is produced from the bones of animals, right? So dead animals, so there we use HCl used for that purpose, preparation of glue or gum from bones. And in the medicines as well as a laboratory reagent, generally dilute HCl is used for various tests and dissolving of some of the substances also. So therefore it is used in case of trace amount, which very less concentration. It is used in medicines also. It is also used in the laboratory reagent in qualitative analysis, right? So as you already studied in first PUC, so for the determination of salts, that is cations and anions, generally we will use dilute HCl, dilute hydrochloric acid, is used for the laboratory reagent also. So these are some of the important uses. So nowhere they have asked this question for annual examination. Go through the old previous question paper. Even if they ask, they can ask for 1 mark. So which is very simple process. Hydrogen chloride is prepared by heating sodium chloride along with concentrated sulfuric acid. So therefore here what happens, NaCl when reacts with H2SO4, so at 420 Kelvin it can convert into NaHSO4. So generally along with that the main product, so that is HCl is produced. And further if you go for the oxo acids of halogen, which means the halogen when reacts with oxygen, they can convert into oxo acids or they can convert into oxide form. That we have seen in case of chemical reactions in case of halogens or 17 group elements. And whenever they react with oxygen, they can convert into oxide form or they can convert into oxoacidic form. So therefore here if you observe, along with the oxygen there is one hydrogen, that is replaceable H plus ion. Generally we call it as the H plus ions, which give the molecule which gives H plus ions are generally in the form of acidic condition. So therefore here if you observe the oxo acids of halogen, means the chlorine is bonded with the hydroxyl group oxygen and further oxygen is bonded to hydrogen. This is generally called as a hypochlorous acid. Remember the structures, they might ask the structures for 1 mark, right? So the oxo acids of halogens, that is hypochlorous acid. Hypochlorous acid was what happens, the chlorine is bonded with the oxygen and oxygen further bonded with hydrogen, which means the chlorine is bonded with the one of the hydroxyl group, that is OH group. And if you go for the chloric acid, in chloric acid what happens, the chlorine has here the valency, so that is 5 bonded, right? So 2 double bonded with oxygen and 1 single bonded with the hydroxyl group. This hydroxyl group is further can be written as O bonded with H, right? So this is completely one group, that is OH. You can also write it as a Cl, right? So this is OH, right? So this is double bond O and this is also double bond O, right? So this is also called as chloric acid. So here I have splitted this OH and I have written it as O bonded with H further. So same thing, same structure, right? The chloric acid can be written like this: chlorine, which is one side bonded with the hydroxyl group with a single bond, and two side it is bonded with the oxygen with a double bond. Similar in case of perchloric acid. Perchloric acid, what happens? So there is a bonding of chlorine with, so here if you observe 3 double bonded oxygens and 1 single bonded hydroxyl, which means here 1 double bonded oxygen is extra. So therefore then it is called as perchloric acid. And if you go for the chlorous acid, so here it is bonded with only 1 single bond, one oxygen with a double bond and another hydroxyl group with a single bond, and that structure is called as chlorous acid. So remember the structures might be asked for 1 mark, right? So if they give the structure of chloric acid, you must write a chlorine single bonded with 1 hydroxyl group and double bonded with 2 oxygen atom, right? So that is the structures of oxo acids of halogen. Okay, further if you go for the next important concept, that is interhalogen compounds, right? So already we have seen interhalogen compounds, we have basic idea. Before that we have studied the interhalogen compounds. Generally whenever the halogens are react with its own halogen of different size, not of the same size but of the different size, they can convert into interhalogen compounds. This we have already studied in chemical properties of 17th group elements, right? So that is the third reaction. Whenever the 17th group elements, which means halogens react with the own elements of the same group, so that is generally called as interhalogen compounds. So generally there are 2 different halogens which reacts with each other. Remember the word 2 different halogens. We are not talking about the same one. Whenever they react with the 2 different halogens, so each other, they convert into interhalogen compounds. Generally they convert into interhalogen compounds, and they are in the form of XX dash, XX3 dash, XX5 dash, XX7 dash, right? So generally it is present in the odd oxidation state that we have already seen: -1, -3, -5, -7, +1, +5, +3, like the odd oxidation state. So therefore they can convert into XX dash, XX3 dash, XX5 dash and XX7 dash. And also we have seen where X represents the larger size halogen and X dash represents the smaller size halogen. So there are some examples for the formation of interhalogen compounds that you can see here. They can be prepared by the direct combination. There is no need of any kind of 2-step or 3-step reaction. Direct reaction of or direct combination of these halogens, they can convert into interhalogen compounds. Here if you observe, chlorine molecule is reacted with a fluorine molecule, right? So they converted into chlorofluorides. Chlorine react with fluorine to convert into chlorofluorides at the temperature range of 437 Kelvin. Similarly, Cl2 plus 3 moles of F2, they will convert into 2ClF3. which means here slow, that is x dash means x is the larger size halogen. Chlorine has a more greater atomic radii when compared to that of fluorine, right? So therefore it is in the form of x dash. Chlorine reacts with fluorine, and that is converted into 2ClF, which means the x dash means the x is always the larger size, right? So this is generally called as x, and the x dash will be of smaller size, right? So this is generally called as x dash. It is in the form of like this x dash bond formation, right? So therefore if you observe, always the x will be the, right, so greater radius element, right? So here if you observe, the fluorine cannot react with chlorine, but the chlorine can react with fluorine, right? So that is the type of bonding which can be observed in case of interhalogen compounds. So therefore x will be always the larger size halogen, right, and x dash will be always smaller size halogen. Therefore it is in the form of x dash. These are generally called as interhalogen compound. Here also if you observe, this iodine and chlorine, iodine is having the higher radius, atomic radius, when compared to that of chlorine. In front of iodine, chlorine looks like a very small. Therefore here also it obeys. I2 plus 3Cl2 will convert into ICl3, iodochlorides, right? Similarly bromofluorides, right? So bromofluorides can be like this. You can prepare by reacting one halogen to the another halogen. There is no need of much steps or more than one step. So therefore we'll call it as a direct combination, because within a single step you can get the product. So therefore these are generally called as direct combination reactions. And for the formation of interhalogen compounds, the halogens must interact in the form of x dash, where x must be always the larger size halogen and the x dash must be always the smaller size halogen, right? So here we have given 4 to 5 examples. Basically 6 examples are there. Out of 6 you must remember any one or any two for the examination. If they give explain interhalogen compound, means you have to write the definition. When two different halogens react with each other, they convert into interhalogen compounds, but they must be always in the form of x dash, where x is generally represented as a larger size halogen and x dash may be represented as smaller size halogen. As we come from fluorine to iodine, fluorine, chlorine, bromine and iodine, right? So iodine has the larger radius or greater radius. So therefore here the radius goes on, increases from fluorine down the group, fluorine to iodine, the atomic radius goes on, increases. So therefore fluorine is more electronegative because its atomic radius is very small. That we have already seen even in case of anomalous properties of fluorine also. So therefore fluorine can bond with all the three, but it must be in the form of larger size halogen that is bonded with the or reacted with the smaller size halogen. Iodine can bond with bromine, chlorine as well as fluorine. But bromine can bond with chlorine and fluorine only, but it cannot bond with iodine, right? Because since it is very smaller than that of the iodine can further bond with the bromine, right? So therefore it must be in the always in the form of, remember this concept, this must be always in the form of x dash. That is very important in this case, right? So you can write any of the example out of 6, all are very simple. And here there are some important points. The first one is these are all covalent molecules and are diamagnetic in nature. Always remember, the interhalogen compounds are always covalent. The bond between the halogen atoms is always covalent, and these are diamagnetic. There is no chance of paramagnetism. So here it is completely diamagnetic in nature. That is very important. Next one is interhalogen compounds are more reactive than halogens, right? So interhalogen compounds are more reactive than compared to that of halogen, except fluorine, because fluorine is highly electronegative. So therefore interhalogen compounds are more reactive than compared to that of the single halogen atom, because the x dash bond in interhalogen is weaker than the XX bond, which means whenever the fluorine bonded with fluorine, the strength is more. Here strength is more, right? So whenever the same chlorine bonded with fluorine, here if you observe, so this is interhalogen because there are two different halogen, one is a larger size, one is smaller size, the strength is less. So therefore what happens, so in case of interhalogen there is a weak bond. Whenever there are two different halogen bonded, we will generally call it as interhalogen. So because there is a difference in the atomic radii, difference in the size of the atoms, so here the strength is very less. You can easily break this bond. But whenever the same sized halogen atoms react, their strength will be very more, right? So therefore what happens, so there will be an for example if we take both Cl, so here Cl strength is more, we cannot break that very easily. So therefore this point is very important. Interhalogen compounds are more reactive than halogens, except fluorine, right? So fluorine can be broken very easily. Sorry, I have written here wrong. You can take it as chlorine bond can be broken with a high strength, you require more amount of energy to break that bond. But whenever there are two different halogen atoms, you can break that very easily. That strength cannot be seen, that more strength cannot be seen in the interhalogen compounds. So therefore, the interhalogens are having the weaker bond, can break that very easily when compared to that of the bond between the same kind of halogen atom. These two are very important. First one is, so all the bonds which are formed in case of interhalogen are covalent, and generally they are diamagnetic in nature. There is no chances of paramagnetic, and interhalogen compounds are more reactive than halogens. The reason for that is because XX dash bond in the interhalogens is weaker than that of the XX bond in case of halogen, except fluorine, right? So one more question they can ask even in case of CET also, right? So why interhalogen compounds are more reactive than halogens? So even in case of annual examination also they can ask why interhalogen compounds are more reactive than halogens, right? So the answer for this is this one, right? So because the XX dash bond in interhalogen is weaker, the XX dash bond in a interhalogen is weaker than compared to that of the same kind of halogen atom, the same kind of halogen, that is XX bond. You require more amount of energy to break this XX bond, but you require very less amount of energy to break this XX dash bond. Therefore, the interhalogen compounds are more reactive than that of the halogen, right? So this is the most important 1 marks question from the interhalogen compounds. And if you further go for the important uses of interhalogen compounds, so interhalogen compounds are generally used as a non-aqueous solvents. Other than water molecule, you can use them as a solvents to dissolve some of the different chemicals, some of the different substances also, right? So they can be used as the non-aqueous solvent. Non-aqueous means free from water, right? So other than water, you can use these interhalogen compounds as the aqueous solvents like chlorofluorides, bromofluorides, iodochlorides, right? So these can be used as the solvents, that is generally called as non-aqueous solvents, right? And they are also used, they are also very useful fluorinating agent. Fluorinating means addition of fluorine. Addition of fluorine is generally called as a fluorinating, right? So similarly, chlorination means addition of fluorine will generally called as chlorination, right? So that we have seen even in case of alcohols, phenols, and ethers also. The reaction of phenols, right? So that is bromination, chlorination, right? So like that reactions we have seen, right? So electrophilic substitution reactions also we have seen. And interhalogen, the reaction of a change with a halogen, right? So that is halogenation reactions also we have seen. During that time what happens, we can use this interhalogen compounds for the addition of fluorine to the benzene. Generally we'll call it as a fluorination. Addition of chlorine to the benzene, we'll call it as chlorination. In that reactions, we can use this chemical substance which are known as interhalogens as a fluorinating agents also, right? So these are the two important uses, and be careful with the question, that is why interhalogen compounds are more reactive than that of the halogen. Or they may ask for 2 marks, what are interhalogen compounds, give example, right? The definition where X represents the larger size halogen and X dash represents the smaller size halogen, and any of the one or two examples is enough for the 2 marks. Okay, once again we'll see what we have learned today, that is preparation of hydrogen chloride, because before this class we have already learned the explanation about the 17 group elements. Along with that, physical and chemical properties also we have seen. But in today's classes we have seen the preparation of hydrogen chloride, very simple, only one step. When the sodium chloride reacts with concentrated sulfuric acid, it will convert into NaHSO4 along with the preparation of HCl. And we have seen the properties, some of the important properties of hydrogen chloride. Generally, when it is in the aqueous solution, which means when you dissolve that in water, it is generally called as hydrochloric acid also. Along with that, we have seen some of the uses, which is used in the manufacture of chlorine for the extraction of glue or gum from bones. Along with that, in the medicines and in case of laboratory agents also, reagents also, we can use that hydrochloric acid. And further, 1 mark important question that we have seen, oxoacids of halogen. So that is hypochlorous acid, chloric acid, that is perchloric acid, and chlorous acid. Just remember how many number of atoms are present, right? So here if you take, it is HClO, right? So that is here if you observe, it is HO3Cl, like this, right? So ClHO3, you can write like this, right? So if you know the molecular formula, it's very easy to identify what is the structure. And remember, wherever there will be a double bond, wherever there will be a single bond, that is very important in case of structures. That is oxoacids of halogen. And perchloric acid and chlorous acid also we have seen. And the next part what we have seen, that is the inter-halogen compounds. That might be asked for 2 marks. When two different halogens react with each other, they generally convert into inter-halogen compounds, and they are in the form of X dash, X3 dash, X5 dash, and X7 dash. Basically it depends on the valency that we have seen, that is a -1, -2, -3 odd oxidation state, -5 and -7, that can be seen, and where X represents the larger size halogen and X dash represents the smaller size halogen. Along with that, we have seen some of the important preparation, right? So these are very simple. Just remember one important point, that is the X must be the larger size and X dash must be the smaller size halogen. And we have seen two important properties of that inter-halogen compound. One is these are all are covalently bonded, and these are generally diamagnetic in nature. You have to remember that one. And the inter-halogen compounds are more reactive than halogens. That might be the 1 mark question. And the reason for that is because X dash bond is in inter-halogens is weaker. We can break that very easily when compared to that of X bond in case of halogen, except fluorine. That is acceptable case. So therefore, whenever fluorine bond, you need very less amount of energy. You can break that very easily. So here I have given the representation why the strength is more and why the strength is less in case of inter-halogen. And we have seen very few uses of this inter-halogen compounds also, and these are very useful for your examination. And this completes the complete information about the 17 group elements or the halogen atoms. And in the next class we'll complete the next one, that is group 18 elements. Right, so there is only 2 or 3 simple preparation, I think. Along with that, we'll see some of the important points which are regarding with the uses of group 18 and why these are heavily used in case of certain phenomena or in case of certain areas, right? So that will continue in the next class. We'll stop here and we'll continue in the next class. Make your notes, as well as I will give these notes in our WhatsApp also. Thank you.